Hello everyone. Okay, this video I'm going to demonstrate calculate the center of mass on discrete system. And last video we demonstrate that if you want to calculate the center of mass on discrete system, the formula looks like this. Yeah, it's take a few time. The formulas look like this. Okay, and right now we want to apply this formula to an example in the textbook. Okay, so right now, okay, because center of mass you cannot see it, so that's why I need to calculate it. Okay, so this is example 9.2. It say it's there's a equicharge. The three mass is connected by the three rod. Okay, and the rod we can ignore its mass. Okay, it's massless rod. Okay, connect these three objects, and the mass of these three objects are m, and 2m, and they form the equilateral triangle. And the length of the one side is, let's just make it capital L. And he wants you to calculate center of mass of this system. Okay, yeah, in this system we ignore the mass of the rod. And I intentionally set up two different coordinates and see if the result will change or not. Okay, in the first one we set the origin at here. Okay, we made the coordinate. We set up coordinate here, and the others, the below example, we set the coordinate origin at here. Okay, I just want to show you if I set up different coordinate system, will the center of mass changes? Intuitively, yeah, it won't change, but let's try it. Okay, so I think I should move this downward a little bit. Okay, and the formula for calculate center of mass, yes, you still remember that, because right now we only have two dimension. It's a two-dimension problem, so we only write the formula for the two dimension x and y, and XCOM always becomes so thin. Yes, I think something must be wrong. Okay, XCOM is equal to summation alpha, m alpha, x alpha, and capital M, total mass of system. And YCOM is equal to the mass of each particle times its own y coordinate and divided by capital M. Okay, so let's try the first system. Okay, in first system, the origin is here. Okay, the origin here is called 0, 0. Okay, and yeah, it's one of the mass is sitting on the origin. Okay, so, and what's the coordinate of this object? Okay, so the x coordinate is L and y coordinate is 0. Okay, that's no problem. And what's the coordinate of the third particle? Okay, the third particle. Okay, so it's an equilateral triangle. So I think we already have enough information. So it's an equilateral triangle. So let me draw a vertical line here. Okay, so this should be L over 2. So the coordinate should be L over 2 and L over 2 and square root of 3 over 2 times L. Okay, so let's coordinate of these three particles in this coordinate system. Okay, so let's try. What's the XCOM? Okay, summation M alpha I alpha. So let's say this is label. This is a particle 1. This particle 2. And this is particle 3. Okay, so it will become M1 x1 plus M2 x2 plus M3 x3 divided by capital M. In capital M, the total mass of system. So it's M1 plus M2 plus M3. And YCOM. It's the same. Okay. Let's write it down. M1y1 plus M2y2 plus M3y3. M1 plus M2 plus M3. Okay. So let's dealing with the denominator first. Denominator is much easier. So M1 plus M2 plus M3. So it gives you the mass of this total mass of system, M plus 2M. So it's M plus 2M. So it's totally 4M, right? M plus 2M. Okay, so M1, so that's M1, the mass M1, the mass of M1 is M, and the coordinate, the x coordinate of first particle is 0, so just put it 0, okay, and the coordinate, x coordinate of second particle, oh yeah, I forgot the mass, okay, the x coordinate of second particle, L, capital L, and the third one, the third particle, the mass is 2m. The mass is 2m. And what's the x coordinate of the third particle in its coordinate system? It's L over 2. Okay, so you can calculate what's the x count. Okay, so I think the answer is I need to calculate myself. The 4m. This is ml plus ml is 2ml. So L over 2. I think the answer should be L over 2. L over 2. Okay, and the coordinate of center of mass, the y coordinate of center of mass. Okay, the denominator is the same, and the numerator, okay, the first particle mass is m, and y coordinate is 0, okay, and the second particle mass is m, yeah, and the y coordinate of second particle is 0, okay, variable is 0, okay, and the third particle mass is 2m. And what is the y coordinate? What's the y coordinate? Square root of 3 divided by 2. Square root of 3 divided by 2 and L. Okay, so so what's the answer is it's 2 divided by 2, so 4, so it will become square root of 4, square root of 3 divided by 4 and times L. So the center of mass, I think the position should be maybe I think it's close to here. So okay. So square root of 3 is 1.732 and divided by 4, 0.416, 13. Yeah, 0.4 something. So yeah, maybe roughly is here. Okay, so this is the x common, x y com under this coordinate system. Okay, let's change. That's the same system, but if we set up a different coordinate, what the answer would be? Okay, so let's see what the answer would be. Yeah, so the same one. Okay, the x com equal to, yeah, the denominator is 4m. We already know that, so we don't have to explicitly write it down. Okay, so in this coordinate system, what's the coordinate of these three objects? Okay, here it's 0, 0, 0, 0, and this one is, I think this is minus L over 2, and what is y coordinate, or y coordinate? I think is minus square root of 3L. Okay, and about this one is L over 2 and L minus 3L. Okay, so in this coordinate system, there's a coordinate of these three objects. Okay, so so let's calculate x com, and the same thing. Okay, this is particle 1, this is particle 2, and this is particle 3. Okay, the mass of particle 1 m, and its coordinate is minus L, 2L, M minus L over 2 plus M, L over 2, M plus, what's the third particle is 2M times 0. It's too close, so I should, okay. So what the answer will be? What the answer will be? X count is it's it's cancel out 0. It's 0. It's become 0. The answer looks like the answer change, but I keep continue. Okay, the denominator is 4m, and the numerator, okay, mass m1, particle 1 is, okay, the y coordinate of particle 1 is minus square root of 3l plus, and particle 2 m, and it's minus square root of 3 divided by 2l, and the third particle mass is 2m. The y coordinate of third particle is 0. Okay. Did I calculate something wrong? No, I didn't calculate something wrong. Okay, so this what this will be. Okay, the mass m will be cancelled out. So this will be minus square root of 3l. So it's minus square root of 3 L. Okay. Okay, so you see in this coordinate, the x count and y count, in this coordinate, the coordinate will be 0 and square root of 3 minus square root of 3 divided by 4L. And the first one, first coordinate system, what's the coordinate of center of mass in the first coordinate system? The answer is L over 2 and the square root of 4 and L. Okay, you see the value, the coordinate value is different, but from system perspective, the center of mass really doesn't change at all, because it didn't change. It's it's coordinate independent, because its value is 0 and minus square root of 3 divided by 4 times L, but actually its position is also just right, right here. I think it's right at here, minus 4.3 coordinate system. Okay. So the coordinate system is, let's see, its x coordinate 0, so it's 0 is here, so, and minus 4.3. I think I calculated something wrong here. So I think it's here, but the position is right. But position is kind of changed. Okay, let me stop this first a little bit. Hello, I'm sorry, because I just feel a little confused about my answers. Okay, so I did some check. Okay, I think the problem is I draw this is wrong position. Okay, this is not. This is, the thing center of mass is not here. I think it's just right in the middle of the. I think because this square root of 3 divided by 2 times L, so the y coordinate is square root of 3 divided by 4L, so I think it should be here. Okay, it should be here. Okay, it should be here. Okay, and this is 3 square root of 3L. And for the other coordinate, the x coordinate is no problem. It's 0, and it's square root of 3 divided by 4 and times L, but it's negative, so it's here. It's here. and this is square root of 3L, square root of 3 and divided by 4 and L. So yeah, the in this coordinate system, the center of mass is here. Okay, and you can see that okay, the coordinate value are different. Yeah, the coordinate value are different. But but if you from the system perspective, the center of mass, yeah, it's right at the middle of this triangle. Yeah, middle. Yeah, it's middle because it's L over 2, and yeah, this is square root of 3 divided by 4, and the total length square root of 3 divided by 2 times L. So it's right at the center of this side, and this is right at the center of this side. And here is 2L over 2. Okay, so its position. Yeah, so its relative position is the same. Okay, its relative position is the same. Okay, that's the rule of position. The relative position of COM is the same. Is the same in different coordinate system. A different coordinate system. Okay, that's why I want to show to you. Okay, yeah, the value, yeah, in different coordinate system, the value is not the same. The value is not the same, but their relative position in different coordinate system is the same. Okay, okay, that's very important concept. Okay. Yeah, different coordinate, different value on the coordinate of center of mass, but their relative position to other particles, to each particle, is the same on different coordinate system. Okay, so that's why I want to say in this. That's why I want to show in this example. So, okay, so I'll start the video here, and we'll see you in next video. Bye bye. And next video I think is about calculating center of mass in continuous system. Okay, and then motion of center of mass. Okay, see you in next video. Bye bye. Yeah.